This video will investigate displacement and velocity. First, we need to understand the difference between a scalar and a vector. A scalar is a quantity that has only magnitude. For example, I drove 5 miles. 5 miles is a magnitude of the distance I traveled. Vector quantity has both magnitude and direction. I drove 5 miles north. 5 miles is the magnitude, north is the direction. Now, let's use this to consider distance traveled versus displacement. Distance traveled is equal to the total distance traveled by an object, and it's a scalar quantity. Displacement is a change in position and is a vector quantity. So here is my son Caleb. He started at position 0 and he is moving to position 2. His distance traveled was 2 meters, however his displacement was 2 meters to the right. Now here he is again going from -1 to +1. Again, same situation, distance traveled was 2 meters, his displacement was 2 meters to the right. Now, let's consider this situation. My son Evan goes from +1 to 2 and back down to -2. If you look at the total distance he traveled now, it's 5 meters versus his displacement was -3 meters. You can tell this by looking at the picture. You can also use the change in position formula. X final minus X initial gives you the change in position. -2 minus 1 gives you -3. Now I want you to practice by finding Dr. Butler's distance traveled and displacement for the following 2 clips. Make sure you put this down in your notes. Go, Dr. Butler. Look at that run. Is he fast or what? You might want to consider asking Dr. Butler to take you on in a little race. Look at that speed. Run fast, Dr. Butler. Let's now consider the difference between average speed and average velocity. Average speed is defined as the distance traveled over the time. It is a scalar. Average velocity is defined as displacement over time, or delta x over delta t, and it is a vector. Let's now look at Caleb. He's about to run. He is going to run a total of 15 yards north. It took him 5 seconds. So his average speed is 15 yards over 5 seconds, or 3 yards per second. His average velocity is 3 yards per second north. Now Evan here is going to run 10 yards north, then go backwards and run 10 yards south, ending at the same place that he began. When we look at his average speed, he ran 20 yards in 10 seconds, so his average speed was 2 yards per second, but his average velocity was actually 0. His displacement was 0, so therefore his average velocity was 0. Now it's your turn. In the following clip, you'll see Evan ride his bike around a circumference of circle of 100 feet. Find his average velocity and average speed. Go, Evan! Now, we're back to Dr. Butler. How fast is he? Use the following clip. Find his average speed and average velocity. Look at that. So fast. You could take him on, though. Is he really that fast? Consider it. Now, instantaneous spin velocity are defined as the speed at a certain instant in time. Instantaneous velocity will actually be the same as the instantaneous speed. Velocity will just include direction. In the following clip, we are going to actually determine Dr. Butler's real top speed. You may want to reconsider actually asking him to take you on in a race. Look at that. It's like a flash. You can hardly even see him. Good luck. To summarize, this video looked at the difference between a scalar and a vector, distance traveled versus displacement, average speed versus average velocity, and we just touched on the idea of instantaneous velocity. We will continue this discussion in class the next period. Make sure you did all of the follow-up. Thanks!